What if I told you there's a special kind of AI that doesn't just look at a picture, but actually learns its very essence? I mean, it creates a perfect, continuous formula for a single image, kind of like a digital artist who can recreate a masterpiece from memory, down to the tiniest detail. Well, today, we're going to talk about a really fascinating new technique that teaches these specialist AIs how to learn faster than ever before.
All right, so here's the game plan. First, we'll get to know these incredible AI artists. Then we'll talk about the one huge problem that's been holding them back. After that, we'll meet a new technique called Strainer, see how it cleverly gets around that problem, check out the honestly pretty amazing results, and finally wrap up with what this all means for the real world.
So to kick things off, let's meet these digital Rembrandts. Now, in the academic world, they go by a fancier name: implicit neural representations, or just INRs for short.
Okay, so instead of storing a picture as a grid of pixels, like a JPEG, an INR learns a single elegant mathematical function that represents the entire image. You can think of it less like a photograph and more like a set of instructions for drawing the image. You just give it any coordinate, an X and a Y, and boom, it tells you the exact color that's supposed to be right there. It's wild. And here is what you get at the end of the day. This picture of a cat? It's not pixels. It's a perfect rendering of that learned formula. The AI has focused so intensely on just this one thing, this one cat, that it's learned it flawlessly, capturing every single whisker with perfect clarity. But, and there's always a but, right? This incredible single-minded focus has a massive downside. It creates what you might call a one-trick pony problem, and it's seriously limited how we can actually use these things.
So here's the fundamental difference. A traditional AI, like a CNN, learns general patterns from thousands of different images, but an IRN learns one image perfectly. The catch? Its knowledge is completely non-transferable. If you want it to learn a new image, say a picture of a dog instead of this cat, it has to get a complete brain wipe. It forgets everything and starts the entire learning process all over again, from scratch.
As you can imagine, that's super inefficient. And it led some researchers over at Rice University to ask a really smart question. What if we could give our specialist artist a head start? What if we could pre-train it on the general idea of what it's about to paint?
And their answer is this new framework they've called Strainer. It's designed to do exactly that, to teach the AI transferable skills, moving it from just being a master of one thing to being a versatile and, most importantly, an efficient learner.
So how does this actually work? How do you build a smarter, more adaptable AI artist? Well, the secret, it turns out, is to let a bunch of these specialist AIs learn from one shared teacher.
Now, this diagram might look a little complex, but the idea behind it is actually super clever. Strainer basically splits the AI into two main parts. You've got a shared encoder, you can think of that as the teacher, and then you have multiple separate decoders, which are like the individual student artists.
So here's the process. First, that shared encoder, our teacher, studies a small group of similar images, let's say 10 different faces. By looking at all of them at once, it starts to understand the general transferable features of a face. Eyes, nose, mouth. Then you take that pre-trained encoder and you hand it off to a brand new AI artist. Now this new artist has a huge head start. It already knows what a face generally looks like before it even starts to paint its one specific portrait.
So, the big question is, does this AI art school approach actually work? Well, let's take a look at the results. The proof, as they say, is in the pudding, or in this case, the painting. Check out this graph. It's plotting the quality of the image over time. That bottom line, that's the standard AI model, starting from 0. See how slowly it learns? But that top line, that's Strainer. It doesn't even start at the bottom. It begins with this huge head start in quality and then learns the rest of the image much, much faster.
And when I say a huge head start, I'm not kidding. The researchers found that right out of the gate, a Strainer model has an almost 10 decibel gain in signal quality. For anyone who works in image processing, you know that is a massive, massive leap. And if the graph didn't convince you, just look at the pictures. I mean, it's literally night and day. On the left, after 100 rounds of training, the standard model is still just a blurry mess. But on the right, the Strainer model has already picked out sharp details. It's not even a fair fight. But here's the part that really blew my mind, the efficiency. To get this incredible head start, Strainer only needs to see 10 images, and it learns from them in under 30 seconds.
Now look at the other guys. Some of their advanced methods need thousands of images and can take nearly 25 minutes or even a whole day of training to get to a similar point. It's just incredibly fast.
Okay, so it's clearly faster, it's better, but what does this actually mean for us in the real world? Where can we apply this?
Well, this breakthrough makes these specialist AIs way more practical for all sorts of demanding fields. We're talking about faster, clearer medical scans from less data, much higher quality upscaling for low-res videos, more efficient video streaming, and faster ways to solve tough problems like removing noise from a photo.
Let's just take medical imaging for a second, because Strainer can learn the general structure of, say, a brain scan beforehand. It can piece together a sharp, detailed final image from way less data and in way less time. In a hospital, where every single second can matter, that's a true game changer.
So when you boil it all down, here's the key takeaway. By teaching the AI to learn general concepts first, Strainer turns a niche, kind of slow, one-trick pony into a truly versatile and powerful artist, unlocking its potential for a massive range of new tasks. And that leaves us with a really fascinating thought to end on. We've seen this work for faces and for medical scans. But now that we have a way to teach an AI the essence of an entire category of data, what's next? Could this work for financial market data? For complex audio signals? For weather patterns? It really makes you wonder where this powerful new way of learning is going to make its next big breakthrough.